welcome to Catalyst Chemistry YouTube channel. As we discussed last class, hybridization of some of the hydrocarbons or carbon compounds. Okay. Three types of hybridizations are there. In this case, sp3, sp2, next one is what? sp hybridization. sp3, that is what is the bond angle of sp3? 109 degree 28 minutes. The structure or geometry of what sp3 hybridization is what? Tetrahedral. sp3 hybridization is tetrahedral. The next one is what? sp2 hybridization. sp2 hybridization bond angle is 120 degree. Next, the geometry is a trigonal planar. Okay. Next one is what? sp hybridization, the bond angle is 180 degree, the geometry is what? Linear. Okay. All of you very well know about the structure of tetrahedral. Next one is what? The structure of planar, trigonal planar you have to consider. Next one is what? Linear structure. Okay. After that, the percentage of S character also we discussed last class. The percentage of S character, just you know very well about that. sp3 is having a 25%. Next one is what? sp3 is having a 25, sp2 is a 33.33. Next one is what? sp is a 50%. Okay. Today we are going to discuss the continue of last video, the relationship between hybridization and percentage of S character. This is one tabular column. Just you have to remember this point, the relationship between hybridization. This is what hybridization column is there. Next one is what? The percentage of S character is there. Okay. Next, hybridization, in this case the first hybridization is what? sp3, the second one is sp2, next third one is what? sp hybridization. Next, percentage of S character, you know very well about that. sp3 hybridization is what? 25%. Next one is what? sp2 is 33.33%. Next, sp is having a 50%. This is a percentage of S character. If sp3 is there, there must be a carbon-carbon single bond. sp2 is there, carbon-carbon double bond. sp3 is there, that is called carbon-carbon triple bond. This is the what? Percentage of S character. And next one is what? Bond. How many bond? 1 bond, 2 bond, next in this case what? 3 bond. Next important point in this case what? Bond length. The bond length of carbon-carbon single bond in picometer. Pico means 10 to the power of minus 12. 1 picometer is equal to 1 picometer equal to 10 to the power of minus 12 meter. Okay, this is indicate what? Picometer. Okay, just see here, bond length of carbon-carbon single bond is there. In this case you have to consider carbon-carbon single, in this case also you have to consider carbon-carbon single, in this case also you have to consider carbon-carbon single bond length. Just see here, the first one is 154 picometer. The second carbon-carbon single bond is 147, the third one is 137 carbon-carbon single bond. Just see here, this series is what? Decreasing order. When the number of bonds, the number of carbon double bonds or number of carbon-carbon bonds is going to increases, the bond length is going to decreases. These two are in what? Inversely proportional to what? Each other. Just here bond length is, this is 154, 147, 137. This is what? A decreasing order. Next one is what? Bond energy of carbon-carbon bond, that is kilojoules per mole. This is the what? Unit. This is also unit of bond length. Bond length means what? The distance between two atoms, that is indicate what? Bond length. Okay. Next, this is called what? Bond energy. The bond energy between what? Two atoms, they are going to represent kilojoules per mole. Okay, kilojoules per mole. The first carbon-carbon single bond, the bond energy is 347. Next one is what? The carbon-carbon double bond, the bond energy is what? 614. The next one is what? Carbon-carbon triple bond, the bond energy is what? 839. In this case what happened? Down the group, this one is indicate what? Down the group you have to consider, means what? In this case tabular column, this is indicate what? Series. In this case what happened? Down the group, in this case what? Bond energy is going to increases, but bond length is going to what? Decreases. Bond length and bond energy, these two are what? Inversely proportional to each other. That is also most important point. Carbon-carbon triple bond is having a what? Highest bond energy. Bond energy means the amount of energy required to break a bond is called bond energy. In this case triple bond is having a what? A very strong bond. Just see here, I will tell you, if the bonds are very close to each other, if the bonds are what? Very close to each other, it is difficult to break. If the bonds means what? If the atoms are close to each other, it is very difficult to break. If the atoms are away from each other, it is very difficult to means it is not difficult to break. That is why in this case what happen, this is having a what, bond length is less. Bond length means what, you know very well about that, the distance between these two atoms indicate what, a bond length. Bond energy means what, the amount of energy required to break a bond, okay, that is indicate what, bond energy. The carbon carbon triple bond, we need much amount of energy, that is what, 839 kilojoules per mole. This is the what relation between hybridization and percentage of what, S character. In this case, what is the final conclusion of this one? Final conclusion is very simple, bond length and bond energy, in this case what happen, these two are what, inversely proportional to each other. If the bond length is high, the bond energy is what, less, like this. Okay. If the bond energy is high, the bond length is less. This is indicate what, inversely proportional to each other. Okay. Next, the next one is what important, that is what, bond line representation. In final examination, annual examination, they are going to ask you write the bond line representation of given compounds, they are going to ask you. Okay. The next heading is, structural representation of what, organic compounds, that is what, bond line representation. Structural representation of organic compound, structural representation of what, organic compounds, structural representation of what, organic compounds, that is indicate what, bond line representation of organic compound. Indirectly what you are going to call, bond line, very simple, this is bond line representation, bond line representation of organic compound, very simple. In this case, 2 to 3 points are there for what, bond line representation. Okay, the first point, do not write hydrogen atom. The first point is what, do not write hydrogen atom, otherwise do not represent the hydrogen atom. Do not represent the hydrogen atom. While you are writing organic compounds in bond line representation, do not write the hydrogen atom, directly skip the hydrogen atom and just you have to draw. Next, after that, the last, the free end, that is also important point, most important point, free end. Free end indicates what, carbon atom. Free end indicates the carbon atom. Okay. The next point is what, satisfy the carbon with the help of what, hydrogen. Satisfy the valency of carbon. Satisfy the valency of carbon. Satisfy the valency of what, carbon. Satisfy the valency of what, carbon. Okay. These 3 points are most important for what, bond line representation. Okay. Next, example for bond line representation we are going to study. Very simple examples. First example you have to take, this is what, I am going to write normal example, after that I am going to represent the what, bond line representation. CH3 is there, next one is what, CH2, next one is what, CH3. What is the bond line representation of given compound? They are going to ask you, very simple bond line representation, you have to represent like this. Okay. CH3, CH2, CH3, very simple, this is a what, bond line representation. You have to represent like this also, no problem. Okay, CH3 is there, CH3, next one is what, CH2, next one is what, in this case what, CH3. Just see here. Okay, in this case, at least means free end indicate what? Free end indicate the carbon atom. This carbon atom satisfy the valency of carbon with help of what? Hydrogen. You have to write here, with help of what? Hydrogen. Okay. I am going to write with help of hydrogen atom, with help of what? Hydrogen atom. Just see here, this carbon containing how many hydrogen? 3, 1 hydrogen, 2 hydrogen, 3 hydrogen. Okay, next here is what? Carbon is there. This carbon containing how many hydrogen? 1 hydrogen, here one is what? 2 hydrogen. This carbon containing how many hydrogens? 3 hydrogen. Okay. This is what? Bond line representation. Don't write the hydrogen and carbon, don't represent. This is the what? Starting example is there. Okay, bond line representation, and this is what? Normal. Okay, yeah. Answer for this one, the answer for this one is what? This is the bond line representation. Next example, CH3 CH double bond CH2. Now tell me, what is the bond line representation? In this case, what? Carbon carbon double bond is there. Okay, like this, totally 1 2 3 carbon is there. This is the what? Bond line representation. CH3 CH, next one is what? CH2. This is the bond line representation. Next example for bond line representation is, these 3 points are most important. Okay, don't represent the carbon and hydrogen, don't represent the carbon and hydrogen. Next one is what? Free end indicate what? CH3 means what? Free end indicate what? Carbon. That carbon satisfy with the help of what? Hydrogen. Okay. Next examples. Next examples you have to take. CH3 is there, CH double bond, CH, next one is what? CH double bond, CH2. Just see here. Okay, this is the what? Compound. You have to check the carbon containing 4 bond, that is compulsory, because of valency is what? 4, no? That is why the compulsory, the carbon surrounding 4 atoms must and should, that is mandatory. Okay. Next, you have to draw the bond line representation of given example. Just I am going to draw. How many carbons are there? 1 2 3 4 5 carbons. Here just here 2 carbon, 3 carbon, 4 carbon, 5 carbon. This is the what? Bond line representation. But in this case, what? This compound containing what? Carbon carbon double bond. Better you have to start numbering 1 2 3 4, next one is what? 5. Just here, in this case 1 and 2 position is there, no? 1 and 2 position is there. In this 1 and 2 position having a what? Carbon carbon double bond. In this case also you have to write 1, here is what? 2, next one is what? 3, this is what? 4, next this is what? 5. Just here, in this case 1 and 2 carbon carbon double bond, you have to write carbon carbon double bond 1 and 2 position, case close. Next one is what? 3 and 4, here 3 is there, here 4 is there, you have to write represent the bond. Okay, this is the what? Structure of bond line representation, very simple technique. Just see 1 and 2 double bond, 3 and 4 double bond, this is the example. Okay. Next you have to take another cyclic examples are there. Okay. Cyclic example means like this, you have to take cyclopropane, you have to take better CH2 representation, CH2 is there, next one is what? CH2 is there, like this. What is the name of this one? They are going to ask you. Cyclopropane, we will study later. What is the bond line representation of this one? This is the bond line representation, very simple. This is a what? Cyclopropane. Next example you have to take CH2 is there, next one is what? CH2, close the bond. CH2 na, this is okay, this is bond. Okay, CH2, next how many CH2s are there? 4 CH2. What is the name of this one? Cyclobutane. How we are going to represent in bond line represent? How? This is the what? Structure of cyclobutane. Now if you want, you can write name cyclobutane. What is the name of this one? Cyclopropane. Cyclopropane. Why you are going to write a cyclo? Because of it is a look like a cyclic ring, no? That is why cyclopropane. Okay, cyclopropane close, cyclobutane is close. Okay, very simple examples. Okay. Next you have to take another example. And another example you have to take nitrogen, everything. If nitrogen is there, you have to represent. Otherwise, they are going to give what? Carbon compound. If triple bond is there, sometime they will give CH3, next triple bond like this. Okay, just here 1, 2, 3. This is what? 4. Next one is what? This is CH2. Next you have to take CH double bond CH2 like this. Okay, now you have to write representation. Better what I told, you have to write the numbering, that is what better. Here you have to start from here 1, 2, 3, 4, 5. Okay. If preference carbon carbon triple and double is there, you have to give preference for what? Double bond. And next, how many carbons are there? Total 6 carbons are there. Total what? 6 carbon. You have to write 6 carbon, no problem. 1, 2, 3, 4, 5, 6. Okay. Next, you have to write carbon carbon double and triple bond. You have to numbering 1 2, 3, 4, 5. Next one is what? 6. 1 and 2 position, this is 1 and 2 position indicate what? Carbon carbon double bond. 4 and 5 is there, here 4, here 5. How many bonds are there? 3 bonds. 1 bond is there, this is what? 2 bond. Next this is what? 3 bond. Like this. Okay. This one is indicate what? Bond line representation of given compound. Okay. Up to this is indicate what? Bond line representation. Okay friends, subscribe and press the bell icon, you will get notified when I am going to upload the video. Okay, thank you.